If you work out of a small shop or you're tired of working on the floor at job sites, you need a workbench like this. I designed this workbench to be heavy duty yet portable while being able to lock into a Milwaukee Packout toolbox. In this video, I'll walk through the whole build process from start to finish, and if you want to build one for yourself, a full set of plans are available below, as well as links to all the hardware. Let's get into it. So I started off by working on the workbench top itself because it is the foundation of the whole project and a lot of our measurements come from it. I decided to go with hard maple for this build because I wanted the workbench to be heavy and durable, but honestly you could use something like 2x4s instead. Once everything was milled, I spent some extra time marking out the grain direction and alternating it for every piece. This is a little bit tedious, but it's the best way to keep the top from cupping or warping in the future. Sadly, my thickness planer maxes out at around 12 inches, so I had to break the glue up into two 8-inch wide sections. Once the glue dried, I used a hand plane to knock down any high spots so that the pieces would feed smoothly through the planer. At this stage, these maple sections are getting pretty heavy, so it's important to support the weight as it goes in and out of the planer. For the final glue up, I did a quick dry fit with clamps to check for any gaps. It wasn't perfectly flat, but I knew I had some work to do later, but it was close enough to move forward with the glue up. Once the glue had fully cured, I used my track saw to trim the ends of the worktop to their final length. With the top cut to size, I could shift my focus over to the legs. The legs here have three big jobs, and that's to elevate the workbench, provide a surface to clamp to, and keep the worktop flat over time. To put the legs together, I went with mortise and tenons. Just like the top, I glued up some hard maple into 2x2 blocks and then cut them to length. I marked everything out and cut the mortises using a combination of the router table, drill press, and some hand tools. From there, I transferred those marks to the tenons and then cut them out on the table saw and the router. Now, since these pieces are getting pretty small, make sure that you're using push blocks and clamps. Don't try to hold these by hand near any blades. Once the fit was dialed in, I took it all apart to drill the mounting holes for the workbench. I started with a 1-inch hole to countersink the hardware, and then added a slot to account for any natural wood movement. Finally, I shaped and sanded the legs so that you could fit a clamp on the front, and I glued it all together. I'll be honest, this was a massive amount of work, and to do it all over again, I would probably just use a solid piece of wood and drill some deep holes for the mounting bolts instead. I gave the legs a quick sanding to smooth out the joints and then moved on to attaching them to the workbench. To get a strong connection to the worktop, I chose dado joints, and to get the layout for the dados spot on, I used the legs themselves as a spacer and double-sided taped some plywood strips down next to it so that it would act as a fence guide. I cut the dados with the router and templating bit. They ended up being a little too tight, so I spent some time cleaning up the shoulders with a sharp chisel. For the mounting hardware, I installed threaded inserts with epoxy. I then used washers and screws to allow the workbench to expand and contract while keeping a solid connection. With the main workbench finished, I moved on to the work holding. I decided to use a moxin vise because it's kind of a game changer if you're wanting to use hand tools, and it makes cutting woodworking joinery much easier. So I got this hardware set from Amazon because it's a little unique from the others. It includes a bushing and a square nut, which adds some extra stability to the whole thing. And so to mount this, I had to drill 2 holes for the threaded rods to recess into. I started with a 1-inch Forstner bit and then switched to a paddle bit with an extension for the depth. I got creative and used a laser level with my squares to keep everything aligned. And so a quick warning here, when you're drilling deep holes like this, especially with a paddle bit like this, it can grab and then it will rip the drill right out of your hands. Ooh. Don't do that. That's called the wrist breaker. Once those holes were at the right depth, I had to carve out a recess for the square nut. I marked out the lines from the 2 holes and used a combination of a Forstner bit and a router with a template to get the shape perfect. If the vise feels sluggish or binds up later, it's almost always because that the nut isn't sitting flush on the inside, so take your time getting that fit right. It should spin totally free like this when you're done. After that, I glued in the bushing, inserted the hardware, and used epoxy to lock the threaded rods into the handles. Once the hardware is set, I transferred those hole locations over to the vise jaw. I turned those holes into slots by marking out a 1/4 inch on each side and cleared out the waste. After that, I laid out and drilled the bench dog holes across the workbench, just making sure to steer clear of where the leg and vise hardware was located. Earlier, I mentioned the worktop wasn't completely flat after the glue up, so I knocked down the high spots using a belt sander and checking it with a straight edge. Once it was flat, I rounded over all the edges on the legs and worktop, while being sure to avoid rounding over where the worktop meets the vise face. You want a nice sharp 90-degree corner there. The last big hurdle before finishing was final sanding. For the worktop, I used a pencil to mark a grid and sanded until every last mark disappeared. This guarantees that you don't accidentally hollow out a low spot and lose your flat surface. For the finish, I went with some Rubio monocoat and I worked it in with the application card and buffed it with a rag. Final assembly was pretty straightforward, but I wanted one last finishing touch on the vise jaw. I glued a piece of leather on the face for some extra grip and then trimmed the excess flush with a razor. Now for my favorite part, getting this thing mounted onto a Packout. I designed this whole build to lock onto a Milwaukee Packout using some 3D printed locking feet that I printed myself. To line everything up, I dropped the feet into the Packout slots, set the workbench right on top, and traced where the locking tab hits. I marked a shallow recess for that tab and cleared it out with a router so it sits flush when pressed down. Finally, I put the locking feet back onto the Packout while adding some glue to them, and then set the worktop back down on top of them. Once the glue dried, I popped it off the toolbox and then drove in some screws to lock those feet in permanently. Just a heads up, these fit most boxes, but you'll need to modify them slightly for the medium toolbox since the built-in handle sits a little too tall. If you want to build one of these for yourself, I put together a full set of plans over at my Etsy shop in the link below. Picking those up is the best way to support my channel so I can keep making videos like this. Thank you for watching.